Hi everyone. So our next topic is solving equations, and we're going to start with equations that you know how to solve, or at least I hope you do. So our first example, suppose you want to solve the equation 4x plus 28 equals 0. I'll give you 1 minute to solve that. Okay, well, the minute's up, so so you're just going to subtract 28 from both sides, and that gives you 4x, right, plus 0 equals negative 28. And now just divide both sides by 4, right, because 4 divided by 4 is 1, leaving you with 1x equals, well, negative 28 divided by 4 is negative 7. So 1x, of course, is just x, and x is negative 7, and there's our solution. And of course, you know how to check, right? If this is the original equation, 4x plus 28 equals 0. If I replace x with the number negative 7, I get negative 28 plus 28 equals 0, or 0 equals 0, which of course is true. And so that confirms that x is negative 7. That's the solution. Right? And in fact, that's the only solution. Right. So this is an example of what's called a linear equation. And you've solved these many times. I'll let you do one more, and then we'll move on to the more difficult equations. Okay. So solve 6y minus 20 equals 0. Okay, so the fact that this is y instead of x, don't let that bother you. There's the equation. You know you're going to add 20 to both sides. And then divide both sides by 6. So you get y is equal to 20 over 6, which you know reduces to, right? So 20 is 2 times 10, and 6 is 2 times 3. So 2 divided by 2 is 1, and you end up with 10 over 3. So y is 10 over 3. And that's the solution, as hopefully you already checked. All right. So again, these are examples of linear equations, ones that you've solved many times before. Right. So the next type of equation we want to solve is called a quadratic equation. Some of you may have heard this word before, or seen this before at some point. But yeah, it's an equation that has this form. A, which is a number, times x, we're using x as our variable, squared, plus b times x plus c equals 0. So this is called a quadratic equation, and we're going to call this the standard form of a quadratic equation, right? So remember, x is the variable, and a, b, and c are just numbers, real numbers, in fact. And there's one condition here: a cannot be 0. Why not? Why, right? A can be anything other than 0. So if a is 0, then remember 0 times x squared is just 0, right? And so you end up with bx plus c equals 0, which is no longer quadratic. This is now a linear equation. So in order to be a quadratic equation, right, you have to have some term with x squared in it, right, or with a square of the variable. Right. It could be y squared or z squared or w squared, but right, It has to contain an exponent of 2 somewhere. Okay, so that's why a cannot be 0. So keep that in mind, right? And in fact, we can actually, in some cases, we can solve cubic equations. We're not, oops, there should be a C. We're not going to see too many of these, if any, where we have an exponent of 3. So that's called a cubic equation. And we might see 1 or 2 examples of those, but, but not too many. And in fact, we're not even going to be able to solve any type of quadratic equation. So even these types of equations, we're not going to solve, any quadratic equation where a, b, and c can be just any real numbers. We will get to that by the end of the course, but in this video and in this section, we're only going to be able to solve a certain portion of these, a certain number of them, right? But not just any quadratic equation. So it's fairly limited, but by the end of the course, we will be able to solve any quadratic equation, right? So any equation that looks like this. Okay, so how are we going to do that, right? First thing is something called the zero product rule. At least that's what I'm calling it. I think the book might call it the zero product property or the principle of zero products. Either way, the zero product rule just says that if you multiply 2 things and get 0, either of those 2 things could be 0. So it says the following, right? If a times b equals 0, and these are capital A's and b's, right? So if a times b equals 0, then either a is 0 or b is 0. And I hope this makes sense because, 3 times 0 is 0, and that tells me that b is 0 here, right? Or 0 times 7 is 0, and that tells me that the a is 0 here. Right? Of course, they can both be 0, right? 0 times 0 is also 0. Right? But if you take any 2 numbers, like 3 times 7, if neither one of those is 0, then of course the product is not 0. In fact, you should know that the product is 21, but of course 21 is not 0. Okay, so pretty obvious, right? If the product of 2 numbers is 0, then at least one of those 2 numbers is 0. Okay, so what does this have to do with quadratic equations? Before we get to a quadratic equation that looks like this, let's do a quick example of just using the zero product rule to solve an equation in maybe a less familiar form. Okay, so here's the example I have in mind. We want to solve the equation x minus 7 times 3x plus 2 equals 0. All right, so how are we going to do this, right? So we're going to think about the x minus 7 as a and the 3x plus 2 as b, because we're just multiplying them, right? This is a times b equals 0. Well, the zero product rule says that if a times b is 0, then a is 0 or b is 0. Right? But a in this case is x minus 7, right? So either x minus 7 equals 0 or b is 0. b in this case is 3x plus 2. Okay, so now we're just solving both of these, or either of them, right? And each of these is just a linear equation. So you should know how to solve x minus 7 equals 0. Obviously, we're just going to add 7 to both sides. And that leaves us with, x equals 7. Right? So there's one solution, but there's another one. And the other one comes from solving 3x plus 2 equals 0. So let's start by subtracting 2 from both sides. And then dividing both sides by 3. Right. And then cancel the 3's. So x is equal to negative 2/3. And that's the other solution, right? So this is unusual. Right? We have an equation with 2 solutions, not just one. Oops. So one of them is x equals 7, the other is x equals negative 2/3. Right? So you have to write them both down because they're both possible solutions. And if you don't believe me, let's check. It's very easy to check x equals 7. Right? If x is 7, then you get the original equation, the one up here, right? Replace x with 7. So you're going to get 7 minus 7 times 3 times 7 plus 2. And we want to check, does that equal 0? Well, 7 minus 7 is 0, right? And 3 times 7 plus 2 is 23. But 0 times 23 is indeed 0. So that works. Right. What about the other solution? Negative 2/3. So now the original equation, which is way up here, right? X minus 7. So that's going to be negative 2/3 minus 7 times 3x plus 2, right? So 3 times negative 2/3, that's the x here, plus 2. Does that equal 0? Well, negative 2/3 minus 7 is going to be negative 23 divided by 3. If you don't see that, that's get a common denominator. But this is something we'll do later in Chapter 7. And it turns out it doesn't matter what this is, right? 3 times negative 2/3 is negative 6 over 3 plus 2. Oh, I'm just out of space. But lucky for me, negative 6 divided by 3 is just negative 2. And negative 2 plus 2 is indeed 0, right? So you're going to end up with negative 23 over 3 times 0, and anything times 0 is 0. So, right, so 7 is the solution, and negative 2/3 is the solution. They both work. So we get 2 solutions to this equation. Okay. And you may not recognize it because it's not in the standard form, but this is a quadratic equation. And I'm going to show you that up here. I'll just cut this off for a second here. So x minus 7 times 3x plus 2 equals 0. This is a quadratic equation. It just doesn't look like it right now. However, if I multiply this out, right, I'm just going to use FOIL here. So FOIL first, x times 3x is 3x squared. I'm not going to use yellow here. I'll still use green. Or let me use blue here, right? So x times 3x is 3x squared. And then x times 2, that's the outside, is 2x. And then negative 7 times 3x is negative 21x. And then negative 7 times 2, those are the last 2 terms, is negative 14. Okay. And one final thing, we can simplify this. Combine like terms, 2x minus 21x is just negative 19x. So we get 3x squared minus 19x minus 14 equals 0, which is exactly ax squared plus bx plus c equals 0. See that, right? So my a is 3, my b, even though this is a minus sign here, right, b is negative 19, and c is negative 14. Okay. So in this form, right, in this form here, this is a quadratic equation in standard form. Right. However, in its standard form, right, in this form here, let me get rid of the purple now, this might not be quite as easy to solve, right, in this form here. So the way to solve it is to first convert it into this form. And for lack of a better term, we can call this factored form. I should use green. This is factored form here, because it's factored. Right? So now you can see sort of the tie-in to what we've been doing in this whole chapter is factoring. So we're not done with factoring. We're going to have to be able to factor, right, something like this in standard form into something like this before we can solve it. Okay, so with that, let's do another example, and this one starting with a quadratic equation in standard form. Okay, so here's our next example. We want to solve the equation x squared minus 11x plus 28 equals 0. And the first thing to note is that this is a quadratic equation, and it's in standard form. Right? In this case, a is, well, the number in front of the x squared is a 1, right? So a is 1. Right? You usually don't see it, but it is there. B is negative 11, and C is positive 28. So when you can recognize what A, B, and C are, then you know it's a quadratic equation in standard form. Okay, so yeah, the first thing you're going to do to solve a quadratic equations, right, step 1, is to write the equation in standard form. Okay, and in fact, they did that for us already, right? Because it's already in standard form, there's nothing we have to do here. Okay, so step 2, right? We are going to factor the left side of the equation, although it could be the right side if 0 is on the other side here. But in most cases, the 0 will be on the right, so we want to factor the left side. Okay, so let's do that down here, right? Sorry, step 2. So x squared minus 11x plus 28. How do we factor that? Okay, so let's go through the process of factoring, right? How many terms do we have? 1, 2, 3. 3 terms. This is a trinomial, right? And well, even before that, the GCF is 1. How do I know that? Because there's a 1 in front, and obviously there's no x over here, so we can't factor out an x. So can't factor anything out, right? And it's a trinomial, so that means we can use the AC method. Although, since a is 1, we can even take the shortcut. The shortcut is just to find two numbers whose product is 28 and whose sum is negative 11. Okay, so I know you've done this many times already. And in fact, at this point, the answer might be obvious to you. At least I hope it is. But if not, let's go through it carefully one more time. So what two numbers have a product of 28? Well, there's 1 times 28, but 1 plus 28 is 29, which is not negative 11. And in fact, it's not even negative. So that tells me the two numbers should be negative. So we can try negative 1 times negative 28. Oops. And that adds up to negative 29, which is, at least it's negative, but it's not negative 11. So let's try negative 2 times negative 14. And negative 2 minus 14 is negative 16, still not negative 11. So, right, so now we can try negative 3 times, oh, it's not divisible by 3, is it? So, right, so let's ignore that because it's not a whole number. But we can divide by negative 4, and we get negative 7. So let's subtract negative 4 plus, or let's add negative 4 plus negative 7 is negative 11, which is negative 11, right? That's what we're looking for. So we have our two numbers, negative 4 and negative 7. And so the negative 4 goes here, the negative 7 goes here. Although, remember, it doesn't matter what goes where, since order doesn't matter. And so that takes care of step 2, right? We did factor x squared minus 11x plus 28 as x minus 7 times x minus 4, or x minus 4 times x minus 7, either way. Okay, so on to step 3. Now we solve the equation, right, using the zero product rule. So step 3, let's do down here. Right, so we factored this as x minus 7 times x minus 4, but remember, this was an equation. This was just the left side. So I'm going to put back the equal 0 now, right? No, let's put it back. There's the equal 0. And we solved one just like this earlier, right? We're going to think about this as a times b equals 0, which means either a is 0 or b is 0. In this case, a is just x minus 7, and b is x minus 4, right? Or vice versa. So if x minus 7 equals 0, then x is going to be 7. And if x minus 4 equals 0, then x is going to be 4. And we're done, right? These are the two solutions, 7 and 4, right? Don't believe me? We can check. So we'll consider this step 4. Let's check. Now, by now, I completely forgot the original equation. It was x squared minus 11x plus 28. This was the original equation, right? Again, we did turn it into this equation here. And if you check this equation, sure, it's obvious, right? 7 minus 7 is 0, and 4 minus 4 is 0. But I would recommend you go back to the original equation. And I'll explain why after I check here, right? So if x is 7, this is 7 squared minus 11 times 7 plus 28. So is that equal to 0? All right, let's see. 7 squared, 7 times 7 is 49, minus 11 times 7 is 77, plus 28. So 49 minus 77 is negative 28, plus 28 is, in fact, 0. So 0 equals 0. Now we know 7 is correct. Right, so here we were checking x equals 7. Now let's check x equals 4. Right? So 4 squared minus 11 times 4 plus 28. Does that equal 0? All right, 4 squared, 4 times 4 is 16, minus 44 plus 28. 16 minus 44. You can use your calculator, but it's negative 28. And negative 28 plus 28 is indeed 0. So now we know x equals 4 also works. Okay, so why are we checking the original equation, this, instead of the easier one, this? Well, suppose you made a mistake in factoring, right? I mean, I'm assuming we're all fairly comfortable with factoring now, by now. But nonetheless, it's still kind of tricky, and some of you might still be struggling with factoring. So if I factored this incorrectly and I plugged these numbers back into the incorrect factoring, it's going to look like it's correct, even though it might be wrong. If you plug them into the original equation, this one here, and it turns out to be wrong, then you're probably going to realize that, hey, I might have factored incorrectly. I might have the wrong factoring, right? So by checking the original equation, you're not only checking that did I do the math correctly, did I do the arithmetic correctly, you're also checking if you factored this correctly, right? So you're doing both. Okay, so my recommendation would be go back to the original equation, the x squared minus 11x plus 28, same one here, and check that instead of checking the factored version. Okay, next example. We want to solve the equation n squared equals 45 minus 4n. Okay, so this is a quadratic equation. And I know that because it's not just n, right? It's n squared here. Right? However, this is not in standard form, right? It's not in the form, say, an squared plus bn plus c equals 0. And you see why, right? Because the right-hand side is not 0. Okay? So to put this in standard form, so we have n squared equals 45 minus 4n. To write this in standard form, we're going to have to make this equal to 0. And the way we do that is sort of the opposite. The opposite of subtracting 4n, we want to add 4n, right? Negative 4n plus 4n is 0. So that means I have to add 4n to the left side as well. Right. Likewise, 45 is on the right. If I want to get rid of the 45, I subtract 45. And if I subtract 45 on the right side, I have to subtract 45 on the left side. Just kind of squeeze that in there. Close enough, right? So now what do I have? I have n squared plus 4n minus 45 on the left side. And on the right side, I just have 0 plus 0, which is just 0. Okay, so, right, so that was step 1, right, in standard form. Oops. Okay. All right, so we know it's in standard form, right? A is 1, B is 4, C is negative 45. Right, step 2, factor the left side. Right, so the left side here of the equation is just this, n squared plus 4n minus 45. So I'll write that down here. We want to factor n squared plus 4n minus 45. Oops, we'll come back to the equal 0 later. Okay, and this is done the exact same way we did the previous problem, right? Since a is 1, all we need are two numbers that when you multiply them, you get negative 45. And when you add them, you should get positive 4. Okay, so the product is negative 45, and the sum is positive 4. Right? So what two numbers multiply to negative 45? So how about negative 1 times 45? And negative 1 plus 45 is 44, which is not 4, right? So that's not right. But it is positive, right? So we have the negative in the right place. The smaller number should be negative. Okay. Can I divide by negative 2? No, because negative 45 is not an even number. Right? Can I divide by negative 3? Yes. Negative 3 plus 15 is 12, but that's not equal to 4. So can we divide by negative 4? No, for the same reason that 45 is not even, and it's not divisible by 4, right? Or any even number. Can we divide by negative 5? Sure. Negative 45 divided by negative 5 is positive 9. So when we add these, negative 5 plus 9, sure enough, we get what we're looking for, right? We get 4. So these are the two numbers, right? We just go in here, we get n minus 5 times n plus 9. Okay. And so step 3, now just solve the equation. In other words, set it equal to 0. Well, I already had the 0 there. Sorry about that. And at this point, you know what to do. When you have two factors, the product is 0. That just means that either n minus 5 is equal to 0 or n plus 9 equals 0. And that just means n is either positive 5, right, or n is negative 9. Okay. So, yeah, and even though we saw this in the last problem, don't get confused with the factors, right? The factor is n minus 5, but the solution is n is equal to positive 5, right? Don't get mixed up with the factor n plus 9 and the solution, which is negative 9. In fact, this will always be the case, right? The solution will have the opposite sign as the factor. One's a plus, one's a minus, right? And we know that simply because we're doing the opposite, right? Instead of n plus 9 equals 0, we have to subtract 9 from both sides. That gives us the negative 9, right? Okay, and these are the solutions. Don't forget step 4. You should check. Right? And in fact, I'll let you do that here. Here's the original equation. Right? Plug in the negative 9 for n. See if you get 0. Plug in the positive 5 for n. See if you get 0. Okay, so you did that. Everything checks out. And there you go, right? So yeah, the only difference with the previous problem here is that the first example was in standard form. This example was not quite in standard form. So you do have to put it in standard form first before you can solve, before you can factor it. Right? All right, let's do another. Okay, here's another one. We want to solve v squared is equal to 64. Okay, so let's go through the process. First step is to write in standard form. Is this in standard form? Well, no, because it doesn't equal 0. Right? Let me remind you, it should be ax, or in this case, av squared plus bv plus c equals 0. And it doesn't equal 0, it equals 64. Right? So that's an easy fix. Just take away 64 from both sides. 64 minus 64 is 0. And we end up with v squared minus 64 equals 0. Okay, so now it's in standard form. Well, you might be wondering, wait a minute, that doesn't quite look like standard form. So let's do that, right? A is 1, again. It won't always be 1. This is just a coincidence here, right? So 1v squared. And now notice there's no v here. So that just means this is 0 times v minus 64 equals 0. So a is 1, b is 0, and c is negative 64. Right? So yeah, not v as the variable, but b as the coefficient, right? Yeah, b could be 0, right? A is the only one that cannot be 0. But b could be 0, and in some cases c could be 0, right? Okay, so now we know it's in standard form. But we don't need the 1 and the 0 here, so v squared minus 64 equals 0. Right? So now we have to factor the left side. Okay. So how do we factor v squared minus 64? Oops. Okay, so this one's a little different, right? Again, the GCF is still 1, but it's a binomial, right? It's only 2 terms. You know, you could write it with 3 terms with the 0 term, but 0 times v is 0, so we usually don't write plus 0. Right, so it's a binomial. So, right, it's either the difference of squares, the difference of cubes, or the sum of cubes. And this is clearly the difference of squares. Right, v squared minus 8 squared. Right, the square root of 64 is 8. So this should look a lot like, right, a squared minus b squared, which you know factors as a minus b times a plus b. In this case, right, a is v, and capital B, don't get confused with lowercase b here. Capital B is just 8. So this should factor as v minus 8 times v plus 8. And that's it, right? We're done factoring. Right? Step 3 is to solve. So now we replace the equal 0, and we just have to solve, we'll do that here, v minus 8 times v plus 8 equals 0. So here's my a, here's my b. V minus 8 equals 0, or v plus 8 equals 0. Well, if v minus 8 equals 0, then v is going to be positive 8. If v plus 8 equals 0, then v has to be negative 8. And again, those are our 2 solutions. Okay, and you can easily check. Well, in fact, I'll go through the process of checking. It's not hard. Remember, the original equation was v squared equals 64. Okay, but if v is 8, then you get 8 squared equals 64, which of course is true, because 8 squared, 8 times 8 is 64. Oops, sorry. So what if v is negative 8? So here's where you have to be careful, right? Because you're not squaring the 8, you're squaring negative 8. Negative 8 times negative 8 is a positive 64. So negative 8 also works, right? These are both solutions. Right? Yeah, so again, be careful, you know the difference between negative 8 squared and negative 8 squared. Right? We're not squaring the 8 and then putting a negative in front. We're squaring the negative 8. Right? And negative 8 times negative 8 is indeed positive 64. Okay, so that's another one. Let's do another. Okay, next one. So we want to solve 6x squared plus x minus 35 equals 0. And first thing to note is that this is in standard form. Ax squared plus bx plus c equals 0. So remember, that's always the first step. Put it in standard form. And we know it's in standard form because it equals 0, right? So a is 6, b is 1, and c is negative 35. Right. Step 2, we want to factor. So here we have to factor 6x squared plus x minus 35 equals 0. Remember, b is 1, so this is 1x. All right, so a is not 1 anymore. And so I think we're really going to have to use the AC method, right? You know, the 35 and the 6 are not perfect squares. Actually, negative 35 will never be a perfect square anyway. Okay, so this has to be the AC method. And so let's go through this carefully. First step of the AC method is to multiply a times c. In other words, 6 times negative 35. And my calculator says negative 210. Okay. The second step of the AC method is to find two numbers whose product, right, is negative 210 and whose sum is, well, 1, right, because that's b. b is 1. So they have to add to 1. Okay, so let's start with, well, if it's not obvious, right, it's going to be negative 1 times 210. But when you add those, you get 209, which is clearly not equal to 1. So that doesn't work. Right? And you could divide by 2. You get negative 2 times 105. Negative 2 plus 105 is 103, which is not 1. So let's move on. I think we can divide by negative 3. You get 70. So negative 3 plus 70 is 67. Still not 1. And you can see this is going to go on for a long time here. And again, maybe you see it right away, but I don't. So I'm going to keep going. Can we divide by negative 4? Nope. Can we divide by negative 5? Yes. And you get 42. So 42 minus 5 is not 1. What is it, 37? Yeah, 37 does not equal 1. So that doesn't work either. Negative 6, I don't think that works. Actually, yes, it does, right? 35 times 6 is 210. So negative 6 times 35 is negative 210. And negative 6 plus 35 is 29. Still not 1. So that didn't work either. Okay, so how about negative 7? Negative 7 times 30 is negative 210. Negative 7 plus 30 is 23. Nope, not there yet. So can we divide by negative 8? No. Negative 9? Nope. Negative 10? Yes. Negative 10 times 21. And negative 10 plus 21 is 11, which is still not 1. Okay, let's keep going. Can we divide by negative 11? Nope. How about 12? Not evenly. 13? I don't think so, but let me check. Nope. What about 14? Yep, so negative 210 divided by negative 14 is positive 15. And negative 14 plus 15 is 1. So those are our two numbers. Again, maybe for some of you that was obvious, but I didn't see it right away. So the two numbers are negative 14 and 15, right? So remember what that means. In step 3, we're going to split up the 1x as negative 14x plus 15x, and then factor by grouping, right? So divide this into the first two terms and the last two terms. From the first two terms, I think we can factor out a 2 and an x, leaving us with 3x minus 7. For the last two terms here, we can factor out a 5, leaving us with 3x minus 7, which is good news. Now we factor out the 3x minus the 7, leaving us with 2x plus 5. And that's it. We can check by multiplying this out, or we can check after we solve the equation, right? So now we're in step 3. Well, let's be clear. Step 3 of the original problem of solving the equation. Right, so now we just have to solve the following equation. 3x minus 7 times 2x plus 5 equals 0, right? So don't forget to put back the equal 0 here. And because it's factored, this is my a, this is my b. So 3x minus 7 equals 0, or 2x plus 5 equals 0. Right. So the first gives you x equals 7 over 3. The other one gives you x equals negative 5 over 2. Okay, so they're not nice numbers in the sense that they're not, integers, whole numbers. But we've seen this before, right? You can get fractions as your solutions. And that's what happens here, right? Okay, last thing to do, of course, is check. And I'm going to leave that to you, except you probably want to use your calculator at this point. Right? So if I take 6 times 7 over 3 squared plus 7 over 3, and then minus 35, do I get 0? So this is one that you could work out by hand, but it's not particularly pleasant. So this is why I recommend using your calculator to check at this point. But if you're going to do it by hand, let's see. So you're going to get 49 times 2/3. So 49 times 2 is 98. So 98 over 3 plus 7 over 3 minus 35. Again, we want to see if that's equal to 0. All right, so 98 plus 7 is 105. And 105 divided by 3 is 35. And 35 minus 35 is 0. So it works, right? So the 7 over 3 is correct. And now I will leave it to you to check the negative 5 over 2. You can do it the same way, or you can just use your calculator. Yep. So as you can see, they're not all going to be easy. Some of them, the factoring took considerable time using the AC method, but it worked, right? So I guess that raises the question, what happens if it doesn't work, right? What happens if none of these, right, add up to 1? Well, then, right, then this would not be factorable. And if it's not factorable, we can't solve it, right? Solving these equations relies on this step 2. It relies on us being able to factor this, right? If what we end up with is something that was prime, and we can't factor it, then this method does not work. Remember what I said earlier, that right, we're not going to be able to solve any equation in this form, right? Any quadratic equation. Because there are some equations where this left side here is prime. And if it's prime, if it's not factorable, then we don't know how to solve that. At least not yet. Right? This is something we will, sorry, I'm making you dizzy here. This is something we will get to later in chapter 11. So that's at the very end of this course. We will talk about other ways of solving these equations. other ways that I think are probably more difficult in most cases than what we're doing. So believe it or not, factoring is probably the easiest way to solve this equation here. Right. There are other more complicated ways, like completing the square. It's not pleasant. And there's another way which involves a formula, and if you don't know the formula, you won't be able to solve it. And some of you probably do know the formula. It's called the quadratic formula. And if you know the quadratic formula, then you didn't need to do it this way. But in most cases, I think factoring is probably the easiest way to solve these types of equations. Okay, so here's an example of that. 3x squared minus 18x equals 0. Okay, like I mentioned, there's other ways of solving this, but the way we've been doing it by factoring is probably best. So first of all, is this in standard form? Well, it does equal 0, and a is 3, right? B is negative 18, right? But there is no constant. There's no number here on the left. So C is 0, right? A is 3, B is negative 18, and C is 0. So it is in standard form. Next thing we want to do is we want to factor 3x squared minus 18x. So I hope this is pretty clear by now. The GCF is not 1. The GCF is 3, right? 3 and negative 18 are both divisible by 3. Oh, and the x. Oh, I almost forgot the x. They both have an x in it. So we can factor out 3x as the GCF. And when you divide 3x squared by 3x, you just get x. Negative 18x divided by 3x is negative 6. And that's it. I think we're done factoring. So here, all we needed to do was factor out the GCF of 3x. Okay, but it's still a product, right? It's 3x times x minus 6, right? So step 3, set this equal to 0 again, right? Because it was equal to 0 originally, and solve. So again, we're going to use the 0 product rule. We're going to set the 3x equal to 0 and the x minus 6 equal to 0. Those are the two factors, right? 3x times x minus 6. Okay, so 3x equals 0. Please don't subtract the 3, right? You're multiplying. 3 times x, right? What's the opposite of multiplying by 3? It's dividing by 3. 3 divided by 3 is 1, so you get 1 times x equals 0 divided by 3, which is 0. Okay, so there's nothing wrong with 0. 0 is a perfectly good number. That turns out to be one of the solutions. Right. The other one is, well, positive 6. So add the 6 to both sides, and you get x equals 6. So again, we get two solutions, x equals 0 and x equals 6. And just to make sure we can check, here was the original equation. If x is 0, well, remember, anything times 0 is 0. So 0 minus 0 is certainly 0. And let's check x equals 6. So 3 times 6 squared minus 18 times 6. Does that equal 0? Right, so be careful. 6 times 6 is 36. So 3 times 36 minus 18 times 6. And using my calculator, 3 times 36 is 108. Sorry, 108. And 18 times 6 is also 108. So 108 minus 108 is 0. 0 does equal 0. So 6 works as well. So they're both solutions. Right. And now you might be asking, so do we always get two solutions? And, I mean, so far, yes, right? Every one of these examples we've done, we've always gotten two solutions here. for quadratic equations. Okay? But the answer is actually no. You don't always get two solutions, right? Sometimes you just get one solution. That's a possibility, right? And if it's cubic, if there's an x cubed, you might actually get more than two solutions. You could get 3 or 4, depending on the exponent. And it is possible to get no solutions, but this is something we'll talk about when we get to chapter 11. And by no solution, I really mean no real solution. But again, we're not going to worry about that here, right? So the answer is never going to be no solution, at least in this section here, in this video. Okay. But we might get one solution. Okay, so here's our next example. We want to solve the equation x squared minus 4x plus 12 equals 2x plus 3. All right, so let's go through the same process here. Is this in standard form? No, because it doesn't equal 0, right? It equals 2x plus 3. So first thing we should do is do the opposite of adding 2x. We're going to subtract 2x from both sides. And while we're at it, we can also subtract the 3 from both sides. Right, so what that leaves us with, on the left, we still have the x squared, but negative 4x plus negative 2x is negative 6x. And 12 minus 3 is 9. But on the right side, we have 2x minus 2x, which is 0, and 3 minus 3, which is 0. And of course, 0 plus 0 is, well, 0. Okay, so now it's in standard form, right? A is 1, B is negative 6, and C is 9. So next step is we want to factor the left side being x squared minus 6x plus 9. And so this one should be a little bit easier. It's a trinomial, right? The GCF is 1. And so I guess we're just going to look for two numbers. Oops, sorry about that. Two numbers, right, whose product is 9 and whose sum is negative 6. So we need them to add to a negative number. So how about negative 1 times negative 9? Negative 1 plus negative 9 is negative 10. So that's not negative 6. Okay, can we divide by negative 2? Nope. How about negative 3? Sure, 9 is negative 3 times negative 3. And negative 3 plus negative 3 is negative 6. So there's our match. So the two numbers here are negative 3 and negative 3, which shouldn't be too much of a surprise here that this is a perfect square, right? It's x minus 3 squared. Okay, so that takes care of the factoring. Now we just have to solve. And usually we want to write this as x minus 3 squared, right? However, we can also write this as x minus 3 times x minus 3. Right, so now we just have to set it equal to 0. Remember, originally this was equal to 0 up here. Okay, so just set both factors equal to 0, right? You get x minus 3 equals 0, or x minus 3 equals 0. Sorry, it's a little sloppy, but that's an equal sign, right? So add 3 to both sides, and we get x equals 3. And for the other one, well, we also get x equals 3. So it looks like we have two answers, but we don't, right? 3 is 3. There's only one answer here, and it's just x equals 3. Okay, so yep, the lesson here is that you can get two solutions. In fact, you usually get two solutions. But not always. This is an example where we only get one solution. And it's x equals 3. And let's check. Right. So the original equation was x squared minus 12x, sorry, x squared minus 4x plus 12 equals 2x plus 3. Now, if you're certain that you did the subtracting right here, right, then you can check this equation too. It probably would be easier, right, because ultimately it's the same equation. And if you plug in x equals 3 here, does that equal 0, right? So you get 9 minus 18 plus 9 equals 0. 9 minus 18 is negative 9, and negative 9 plus 9 is 0. So 0 equals 0, right? So yes, x equals 3 is correct. Okay, but again, the first thing is you got to make sure that it's in standard form, right? The right side has to be 0. Okay, so yeah, one mistake is that people try to factor this, because this is also a trinomial, right? What two numbers multiply to 12 and add to negative 4, right? It turns out there aren't any. Wait, because negative 6 and negative 2, that's negative 8. Yeah, so don't try to factor this, because if the right side is not 0, then that doesn't help. Okay, you have to put it in standard form, right, so that it equals 0 before you factor the left side. Keep that in mind. Okay, we'll do a few more. Let's solve y cubed equals 25y. So the first thing to note here is that this is not a quadratic equation. And up until now, we've only been solving quadratic equations. And so you might ask, well then, do we even know how to solve it, right? Even though it's not a quadratic equation, we can solve this one. And it's done the same way, right? Standard form, which in this case just means, does it equal 0? Well, no, it equals 25y. So first step is just subtract 25y from both sides. Okay, so y cubed minus 25y equals 0. Right. The next step, of course, is to factor the left side. The left side here being y cubed minus 25y. So let's start with the GCF. Right? It's not 1, even though this is a 1 here. They both have a y in it. Both terms have a y. So we can factor out the y. Take out the y, and you're left with y cubed divided by y is y squared. Negative 25y divided by y is just negative 25. Okay, so that's factored. But is it factored completely? No. Remember, 25 is a perfect square. It's 5 times 5. 5 squared. So this is your a squared minus b squared, right? It's just a plus b times a minus b, or vice versa. Right? So by now, you can factor this as y minus 5 times y plus 5. Now it's factored completely, right? So only one thing left to do. Now we want to solve the equation y times y minus 5 times y plus 5 equals 0. Remember, this equals 0 here. All right. Well, here we have 3 factors, right? We have y, so we set that equal to 0. We have y minus 5, set that equal to 0. And y plus 5, set that equal to 0. So in this case, we actually get three answers. We get, well, the first one is just y equals 0. The second one is y equals positive 5. And the third one, right, just take away 5, you get y equals negative 5. Okay, so this was a little bit of a tricky one because it wasn't a quadratic equation. You see the y cubed here. That just means you're going to get three solutions. You know, if you ever see, you know, x to the fourth, you could possibly get 4 solutions, and so on. So you're not going to see a lot of these at all, maybe 1 or 2. So you just do it the usual way, right? Put it in standard form, make it equal to 0, then factor it. In this case, we had to factor it by 2 methods, the GCF first, and then by the difference of squares, right? Your a squared minus b squared here. By now we all know it's a minus b times a plus b, right? Yeah. And then you just set it equal to 0 and you set each factor equal to 0. Okay, let's do a couple more. Okay, we want to solve x plus 3 times x plus 8 equals x. Okay, and this is a bit of a tricky one too. Okay, so the problem is some of you might be thinking, wait a minute, this is already factored, right? This is like the very first one we did, in which case we just set these equal to 0, right? But that doesn't work because, look, it doesn't equal 0. Right? It's not in standard form. Right? It equals x. So if you did that, you would have gotten the wrong answers. Negative 3 and negative 8 are not correct. And you can check, right? What you end up with is 0 equals negative 3, which is not true. And for the other one, for negative 8, you're going to end up with 0 equals negative 8, which is also false. So yeah, that would have been nice and easy, but it doesn't work. It gives you the wrong answers. Okay. So again, you just have to follow this step by step. We need this in standard form. Okay. So, yep, let me just write it down again. X plus 3 times x plus 8 equals x. So standard form means it has to equal 0. So let's just subtract x from both sides. And if we do that, we get, right, this is our step 1 here, x plus 3 times x plus 8 minus x equals 0. Okay, so now it equals 0. Now it's in standard form. Or is it? Right, remember what standard form is. Ax squared plus bx plus c equals 0. Okay, what's a, what's b, and what's c? Right, I have no idea. For one thing, where do I see an x squared? I don't see it here. Right? So the problem is that the left side is not in standard form yet. This is factored here. We have to unfactor it, right? We have to multiply it out. Okay, so let's do that. All right, so just FOIL it out, right? First, x times x, there's the x squared, right? And then x times 8 is 8x. And then 3 times x is 3x. And then 3 times 8 is 24. So what do we get? We get x squared. 8x plus 3x is 11x. But don't forget this minus 1x, right? 8 plus 3 minus 1 is 10. So this will be 10x plus 24. Got it? All right. Now we know what a, b, and c are, right? Now this is in the correct form. In fact, let's write it down. Ax squared plus bx plus c equals 0. So here a is 1, b is 10, and c is 24. Okay. So we need that because now we want to factor x squared plus 10x plus 24. So usual question, what two numbers have a product of 24 and a sum of 10? Okay. So we usually go through this. I guess maybe I'll do it one more time very quickly. It's not 1 times 24 because that adds to 25. It's not 2 times 12 because that adds to 14. It's not 3 times 8 because that adds to 11. It's got to be 4 times 6, right? 4 times 6 is 24, and 4 plus 6 is 10. So yep, the two numbers here are 4 and 6. Positive, 4 and 6, right? And last step. We want to solve the equation. So it's already factored. And now just set it equal to 0. Right? And to do that, you just set the x plus 4 equal to 0. And the x plus 6 equals 0. So take away 4, take away 6. We get our usual two solutions. X equals negative 4, or x equals negative 6. And you can check. It's always a good idea to check. Go back to the original equation. In this case, x plus 3 times x plus 8 equals x. Right. And in fact, I'll check one of them. I'll check the negative 6, right? Negative 6 plus 3 times negative 6 plus 8, does that equal negative 6? Well, let's see. Negative 6 plus 3 is negative 3. Negative 6 plus 8 is 2. And sure enough, negative 3 times 2 is negative 6. So negative 6 equals negative 6. So we know that negative 6 is correct. And even though I didn't check it, you should check yourself that negative 4 is also correct. Right. Just because one works doesn't mean the other has to work. You really should check both separately. Okay. So that's it, right? This was a tricky one because it was not equal to 0. It was not in standard form. Right. And you can see now why the two answers we got earlier, the negative 3 and the negative 8, were wrong. Right? It's negative 4, negative 6. Okay. One more. All right, so I think I saved the hardest one for last. We want to solve 3x times x minus 3 equals 2 times 1 minus 2x. Right, so I hope you've been trying to solve these on your own. This one's pretty doable as well. First step, of course, standard form. Right? Ax squared plus bx plus c equals 0. Not even close, right? This is not equal to 0, so it's not in standard form. Right? And in fact, there's no x squared either until you multiply this out first, right? So expanding this out, you're going to get 3x squared minus 9x. And on the right, when you distribute the 2, you get 2 minus 4x. So we should add the 4x to both sides and subtract the 2 from both sides. I can squeeze that in here. And when we do that, we get 3x squared minus 5x minus 2 equals 0. That's supposed to be a 5, right? Okay, good. All right, so now it's in standard form, right? A is 3, B is negative 5, and C is negative 2. So the next step is to factor the 3x squared minus 5x minus 2. And we've done one like this earlier. This is the AC method. Right? A times C is 3 times negative 2, which is negative 6. So what two numbers have a product of -6 and a sum of -5. Well, let's see. Let's try 1 times -6. So what's 1 minus 6? 1 minus 6 is -5. Got it right away. Right? And I don't know, maybe you tried a -1 times 6. -1 plus 6 is +5, which is wrong, right? It's not -5. But when you have the wrong sign, right, a plus instead of a minus, yeah, just switch the signs around, right? Make it a +1 instead of a -1, and a -6 instead of a +6. And that always works, right? So yeah, the two numbers are 1 and -6, right? Not -1 and +6. So yeah, the next step is to split up the -5x as +1x minus 6x. And then factor by grouping. So you factor out the x, and you get 3x plus 1. On the right, you factor out a -2, and you get 3x plus 1. So factor out the 3x plus 1, which multiplies x minus 2. Okay, so we're done factoring, right? So only one more step. Step 3 is to solve the corresponding equation. 3x plus 1 times x minus 2 equals 0. Right? Again, that equals 0. If you keep forgetting, then just keep writing equals 0. I don't know, I always kind of omit that because I'm concentrating on the factoring part here rather than the equals 0. Right. But now in step 3, we set it equal to 0. And at this point, this should be the easy part. 3x plus 1 equals 0, or x minus 2 equals 0. So yep, you're going to get x equals -1/3, or x equals +2. Right? And again, I don't think I mentioned this, but on Connect Math, you probably put in the -1/3 and the 2 separately and just use commas, a comma to separate the two solutions. I'm not picky about that, right? So you can write it this way, you can write it this way. Right? In other words, you can write the two solutions separately as x equals -1/3 and x equals +2. Or you can just write it as x equals -1/3, comma 2. Or, you can even write it as a solution set, -1/3 and 2. That's being a little fancy, but if Connect Math wants it as a set, then write it as a set. But, on a test, I am not going to be picky about how you write it at all. As long as you have them both, right, that's good enough. All right, that's probably about as hard as it's going to get here. Again, just remember to put it in standard form first, then do the factoring. And in most cases, it's the AC method. In some cases, you might just need difference of squares or something like that. And then after you factor, you just set all the factors equal to 0. And then you solve. So 3 steps. Once you get used to it, it's really not that hard. But again, it's practice. Just get a lot of practice with this. There's plenty more problems in the homework, so do as many as you can.